Hello again, all. We are back for 7.4 talking about measuring angles, and hopefully you all remember some of the basics on angles. So of course an angle is formed by two rays going different directions, and those rays have to share a common endpoint. So here we have rays AB and AC, obviously going different directions, and A is that shared endpoint, which becomes the vertex of the angle. We can name angles a few different ways. The most common way is to use our 3-point angle notation. So we use our little symbol that means angle, and then we would name the angle in order of its points, but of course the vertex point has to be the middle point there. So we could name this angle BAC, or we could name this angle CAB, but A always has to be that middle point. That is the huge emphasis right here. So in your notes, I would highlight or star or circle that. And when we talk about angles, we have an interior and an exterior. The interior is how the angle opens up from each other, and then the exterior is on the outside there of that those two rays. So now we get into some problems involving angles. So we have here, what are two other names for KLM? So if you haven't tried this, or sorry, KML. If you have not tried this on your own, go ahead and take a moment to try to figure that out. I see that KML is this angle right in here. So another way that I can name it is angle 2. They show me that there's a 2 inside of here, which is kind of like that angle's nickname. Then we can really call an angle anything we want. In my class, sometimes I call them really weird names, but we can call it anything we want as long as we define that that is the angle. Two other ways that hopefully you could have figured out, or one other way, my apologies, is L, M, K. So I'll make that capital to match. And again, my M, my vertex, is in the middle. And then B asks a really great question. So would it ever be correct to name this angle that we were just dealing with, this angle right here, would it ever be correct to name that angle M? So think about that for a second. We've got M here could relate to the angle that we were just dealing with. So like here could be angle M, or M is also the vertex for this angle, or M is also the vertex for the larger angle created by adding them both together. So the answer there would be no. We cannot use M as the name of the angle because it's not specific enough. It would leave too much question of which angle is it that you're actually talking about. So here, take a moment and go ahead and name in 3 different ways the shaded angle that you see up here. So pause the video, give this a shot. I'm going to move on here in just a second. So for number 1, easy first answer is angle 1. There's a 1 inside what I see. That's what they've kind of nicknamed that angle. The next one, again, keeping B in the middle as your vertex point, we can call it angle ABC. And always we can flip it around and just call it CBA, keeping that vertex point in the middle of my angle name. So especially if you did not try number 1 on your own, make sure you did number 2 on your own. The easiest way to start is calling it angle 2 because I see there's a 2 on the inside of here, the angle that I'm talking about. And then those 2 other ways that you should be able to figure out, J, K, M, keeping K in the middle, and M, K, J. So one way that we measure angles is in degrees. Another way that we'll talk about things on the unit circle is dealing with radians and all that sort of stuff. That gets into trigonometry, which is more math 2. But to indicate the measure of the angle, we write a lowercase m in front of it. So this m right here really means the measure, and then this means the angle. And then we have to know what we're talking about. So that right there reads the measure of angle A is 62. And since we said the measure of, we don't necessarily have to put the degree symbol, but I still like to put the degree symbol. So my suggestion is always attach that degree symbol. And another shorthand notation, you'll want to check with your teachers about this, but I am perfectly fine with this, is that little symbol there is really showing if I have an angle opening up and it has a degree measure, what is it? So we, as mathematicians, have kind of shorthanded that into this symbol, and that arc can be smaller or bigger or whatever. So we could say that symbol for A is 62 degrees. So that also would say the measure of angle A is 62 degrees. So a circle, you obviously know what a circle is. It's all of the points that are equidistant to a center point as they rotate around. So we have our protractor here, which is a half circle that lets us measure our angles. So hopefully you've done some protractor work before. We would check as this ray goes out and it goes through my 0, that indicates what set of numbers to use. Oops, my apologies. So here we're using that inside set of numbers. So as we open up and we come here to read the angle measure, we look at the inside set of numbers, which right here between the 120 and the 130 would be 125 degrees. Now what if when I put an angle on a protractor, one of them doesn't go through the 0? Well, all you have to do is pick what set of numbers you use, and yes, you can actually determine that on your own. I like to use the outside set of numbers just because I think they're easier to look at. So we could determine the size of the angle by just figuring out the difference between its two locations. And because we know that angle sizes are always going to be positive, we again use an absolute value expression. So I'm going to take my larger value first, which over here looks to be something like 147 maybe, minus my lower value over here, which is between 40 and 50, so it looks to be 45. I can just think about 47 minus 45 and I get 102. So we're going to say that approximately, and especially when I take the absolute value, it stays positive. Approximately that angle is about 102 degrees. And of course you remember your right, straight, acute, and obtuse angle classifications, so hopefully that is just a refresher for you. So take a moment, use the diagram below to figure out the measures of these 3 angles. I'm going to take a coffee break, so you can go ahead and let this play for a second. So angle DAF is from D through A to F, and we see that since F is at the 0, we can just use that set of numbers, which is the inside set of numbers, go up the inside set of numbers. We see that DAF is 90 degrees. Now when we look at BAC, we again get fairly lucky here. So B through A over to C. So again, B goes through 0, or the ray from A to B goes through 0, so that now makes me use the outer set of numbers. Using the outer set of numbers, I come up here and find out where does my ray going to C go through. It's right between 20 and 30, so we say that looks to us to be 25 degrees. Now DAE is where this actually gets challenging. So DAE, I'm going to highlight in purple, D through A up to E, so we see that neither of these are at the 0. So I'm going to have to use that absolute value expression. So I find out where is D and where is E. And again, this is when you can choose your set of numbers. Apparently my green pen is not working today. So E is at 110 and D is at 90. So again, it's easiest if we do the subtraction bigger value first. So this would be absolute value of 110 minus 90. 110 minus 90 gives me 20. Don't even need to adjust it for absolute value. It's already positive. It stays positive. So you would see that this angle right here would be 20 degrees. So congruent angles. We discussed congruence when we were dealing with segments. Congruence does the exact same thing with angles. If we say that 2 angles are congruent, it means that they are exactly the same. Their measures are identical. So we can say this a few different ways. We could say the measure of angle A is equal to the measure of angle B, but to shorten that up a little bit, we could then just say that that means angle A is congruent to angle B. We could also write it as saying because they are congruent, then we know their angle measures are equal. So kind of the statement works both directions. So down here we have this this set of lines that all connect, and we see all these different symbols here, and these angle symbols are actually very important to us because where I see 1 tick mark or 2 tick marks, or like 2 angle markings I guess, or 3 angle markings, again my green pen is not working today, let's grab a highlighter, right here and right here. All of those are actually telling me that those are congruent with each other. And then if I run out of those, if I don't want to put 4 or 5 or 6 arcs, then I can start to actually add hashes through the arcs. But we don't get there until we have a very big image and a lot of angles to work with. So number 6 asks if EFD is 75. Well, EFD, let's identify where it is. It is right here. So the angle of EFD has 1 tick mark on it. Then what is the angle of JAB? So I find JAB, and I see that that angle also has 1 arc measure like notation on it. So I know that they are congruent and they must have exactly the same degree measure. Then I do the same sort of thing looking for GHF. So GHF, so I start at G, go to H, go to F. I see I have 2 tick marks there. Then it asks me about JBC, so I start at J, go to B, go to C. I again see that that angle has 2 of the arc measure notations there, so I know that those are going to be congruent angles. Their measures are going to be equal. So I see that JBC must also have an angle measure of 130. Now this is where it all starts to get really fun. So the angle addition tells me that if I see one big angle formed out of multiple smaller angles, I know that those smaller angles add up to give me that bigger angle, assuming that all of them are adjacent, that they have to be touching, sharing the same vertex, right up against each other. So here, we're told that DEF, so when I look at DEF, start at D, go through E, go to F. Well, it looks like a straight line, but we can't assume that until we're told that it is a straight angle. So we know that it's going to sum to 180 degrees. That's what straight angle tells me. Now, since we're told that DEF is a straight angle, I really know that those 2 smaller angles add up to that bigger angle, and therefore I can set up an equation. So I'm going to take my, I'll go ahead and write this out. So DEF plus angle CEF is equal to 180 degrees. So then I can plug in what I have for DEF. And I'm going to go ahead and drop my degree symbols for a minute, and then I'll bring them back. And I have to always look for like terms. That's the biggest trapdoor that people like to fall into. So 11x is like term with 2x. Negative 12, do not forget your sign out in front of the value, is a like term with 10. And of course, the right side of my equation, can't forget about that, equals 180 degrees. So I add up my like terms. I get 13x. Negative 12 plus 10 still leaves me with a negative 2. And that's equal to 180 degrees. Now we all know how to solve our equations, or at least hopefully know how to solve our equations. So I'm going to add 2 to both sides. To get rid of the constant value first, always leave your variable value, deal with that last. So 13x now equals 182. And to get rid of the fact that that 13 multiplies, we're going to have to divide. So we divide on both sides. And from there, I see that x is equal to 14. Now notice that is not 14 degrees. X is a value contained within degree measures. So x itself is just a variable value. It's just an integer. It is inside of a degree measure. So to figure out how big DEC or CEF are, I need to go back and plug it in. So to figure out, let's say, DEC, I need to use the expression 11x minus 12, but now I know that x is 14. So I can say it's 11 times 14 minus 12. 11 times 14 is 154. And when I subtract 12 away from it, I get 142. This is now degrees. So I could come up here and say this is 142 degrees. I'm running out of space, so I'm actually going to clear my work from DEC. Let's solve now CEF. So I'm going to use the 2x plus 10 expression and plug in my x being 14. 2 times 14 is 28, and 28 plus 10 is 38. That again is going to be our degrees, so we could come up and say this is 38 degrees. And when I add those up, I see that it does in fact equal 180, so that would indicate that the work I've done is correct. So make sure that you try this one on your own. You're not going to get any benefit unless you practice on your own. So set this up, try it on your own, pause the video because I'm going to dive back into it in just a second. So ABD we see is the sum of these two angles. Be careful because sometimes they're going to tell you an angle measure, and it's going to be equal to one of your smaller angles. And from there you have to solve for x and then be able to plug in for your ABD here in this situation is still the sum of both angles. So we're going to set up the equation that 5x plus 4 plus the 8x minus 3. Now notice I don't apply parentheses to this. We could have our parentheses here and there and there and there. Because I know that I do what's inside the parentheses. I know that they're really not necessary. I might as well get rid of them and go ahead and start looking for like terms. So again, when I go look for like terms, add variable terms. And I look at constant terms, watching out for any sign that's in front of it. So my 5x and my 8x give 13x. My 4 and my negative or my minus 3 give me a plus 1. And I know that these together are equal to 79 degrees. Now the trap door that I want you to fall into here is thinking that this one is going to add and make a nice perfect 80, but the one does not add. The solve we have to get rid of that one. So we subtract it. That leads me to 13x is equal to 778. And to solve for x then, of course we do division. And 78 divided by 13 is 6. Again, that is not a degree measure. That is our value of our variable that we're then going to plug in to find our degree measure. So let's take it up here. We're going to plug it in. Let's do the small angle first. So 5x plus 4, but now that becomes 5 times 6 plus 4, which becomes 34. Gravity still works. That's a good thing. If we're going to solve our bigger angle here, do 8x minus 3, but really we replace 6. 8 times 6 is 48. Then minus 3 is 45. And if I add those up, I see that I get 79, which indicates that what I've done is correct. So we get that our smaller angle there is 34 degrees, and that would be angle DBC. And our larger angle, 45 degrees, is right here. ABC. And we have one more problem. So especially if you made any mistakes on those previous two problems, try this one on your own before you let yourself watch the solution. I'm trusting you guys to hold yourself to the honor system. So we see that this is a straight angle. We know that straight angle indicates that it sums to 180 degrees. So instead of writing out all the work, I'm just going to jump right in. I know that 6x 20. My obtuse angle, or at least what looks to be obtuse, plus 2x plus 4, my angle that looks to be acute, will sum 180 degrees. Gotta have our degrees in there. So look for your like terms and deal with this problem based off of 6x and 2x and then constants 20 and 4. So 6x and 2x can be 8x. 20 and 4 combined give me 24. That's all going to be equal to 180. Now we start our solution process to isolate the variable. So take away 24 from both sides. That is going to leave 8x equal to 156. We know that in order to isolate that x, we need to then divide. And when I divide by 8, my first non-integer answer that I've gotten, 19.5. That's fine. That's not an integer. We're not always going to have nice neat numbers. But again, we're not done. That is just my variable value. I need to plug in to find the actual angle sizes. Let's go ahead and take our obtuse angle first. So plugging in 19.5, I have 6 times 19.5 plus 20. 6 times 19.5 gives me 117. When I add 20 with that, I get 137 degrees. And that is an answer for angle SQT. So measure of angle SQT equals 137. And we'll see if I have enough space over here. 2 times 19.5 plus 4. Then we do that multiplication. 2 times 5 gives me 39. I add the 4 with it and get 43 degrees. And when I look at adding 137 plus 43 does sum to 180. So we know that that is correct. And this is measure of angle SQR. Cool. So please in the discussion board, let me know if you have any questions, concerns, anything issues. Any of this that didn't make sense, I will make another video to supplement this material. Or if you ask me questions from your homework, I will jump on and solve those problems for you, help you out. Aside from that, have a wonderful day. Keep working hard.